Hi, so we're going to have a look at some conditional probability today. So this tends to be one of the topics in statistics, whether you're doing A-level math or IB maths, that people always ask me for a little bit of extra help with. So just going to have a really quick recap of some of the more basic probability, set notation, Venn diagrams, and then we'll get going straight with some conditional probability. So in this question then, we're told that the probability of A is 0.3. So anything in that circle A in the Venn diagram is 0.3. Probability of B, so anything in the B circle has to add up to 0.4. And the probability, remember that U here is or, so A or B has to add up to 0.6. So the first thing I want to do then is I want to know the intersection. So I always really want to put this in my Venn diagram first because then I don't make mistakes. So to get that, so remember that intersection is the probability of A and B both happening. So to do that, I'm going to add the probability of A and B together, which is 0.7. Okay, so, however, I know that actually A and B have to add up all together to make 0.6. So if I do 0.6 take away, 0.7 take away 0.6, I get the crossover. I'll get that intersection. So I know, therefore, that the probability of both A and B happening is 0.1, and I can put that straight in my Venn diagram. Okay, so now I can fill in the rest of my Venn diagram. I know that A has to add up all together to 0.3. I know that for A and B to happen 0.1, so A on its own must be 0.2. Good, they add up to 0.3, that's done. The probability of B is 0.4, so this means that 0.1 is going to need to be added to 0.3 to make 0.4 altogether. And I know that I've done that correctly. So all of that in my A or B adds up to 0.6. And I know that here, so in my set, so if I just put my squiggly E there for my universal set, I know that 0.4 is the probability of A or B not happening. Okay, so let's have a look at this conditional probability then. So that will be something like the probability of A happening given that B has already happened, okay? And we have that line here. So when we've got this line here, we know it's conditional probability. As soon as we see that it's conditional probability, we know that we need to restrict our sample size. We're now not thinking about the whole set anymore. We're only thinking about what's happened before, given what something's happened. So in this particular one, we are just focusing on the fact that B has happened. So that means that the probability of B happening is 0.4. So I'm going to put that on the bottom of my denominator because I'm just thinking about this part now. I'm not thinking about my universal set anymore. I want the probability of A given that B has already happened. Okay, so if I look at B then, what's the probability of A happening given that B's already happened? Well, the only bit that counts is 0.1, isn't it? That's the only bit that's inside B and is also to do with A. So the probability of A, given that B's already happened, is going to be 0.1 divided by 0.4, which we can simplify to a quarter, and if we wanted to put it in decimals, would obviously be 0.25. And that is all we do. So let's have a look at a exam question. So this was an 8-mark A-level exam question. You are told some information. I've already quickly got my Venn diagram all sorted. Always draw your Venn diagrams, makes it so much easier. So we're told, this time we're actually told the probability of A and B happening. So remember, that's what I want to put into my Venn diagram first of all. So I'm going to put 0.3 there. That's my intersection done. The probability of A happening is 0.4. So that's all of A needs to add up to 0.4. Therefore, the probability of only A happening is 0.1. The probability of B, that all of B has to add up to 0.5. So 0.5, take away that intersection, take away 0.3. would be 0.2. Okay, perfect. Okay, I can actually work out my first quite easy 2-mark question. That's telling me to work out the probability of A or B. Remember, that's anything in A or B. So I'm going to add my 0.1 together with 0.3 and 0.2. So the probability of A or B is 0.6. Okay, with that then, I can now just add my 0.4 to the outside. So what probability of not A or B? I've now finished my Venn diagram. That's going to help me when I get on to part C. Right, let's look at B. We've just been through one like that before. So the probability of A, given that B has happened. So remember, we're going to restrict the sample size. We're not thinking about the whole universal set anymore. We are just thinking about B. So let's just put our B here. This is what we're thinking about now. Okay, so I don't care about anything else in my universal set. I just care about B. So the overall probability, what's going to go on my denominator, that will be 0.5. Okay, so that was the probability of B happening. So B's happened. Now think about what the probability of A, given that B's already happened. So the probability of A is going to just be that intersection part, because remember, we've restricted it just to the circle of B. So that's going to be 0.3 over 0.5. which is 3/5, which is equal to 0.6. So the probability of A, given that B's already happened, is 0.6. Right, this last one, I'm going to get rid of my colours there to help with this one. So remember, when you've got that little dash above, that means not. So the probability of not happening, okay? Probability of A not happening. And here we've got the conditional probability. We've got that line. We know it's conditional probability, and we want to find out the probability of A not happening given that B's not happened. Okay, so the first thing I'm going to do, remember, is I'm going to think about what's happened first. Okay, so given that B's not happened, I need to think about everything in this Venn diagram that's not anything to do with B. Okay, so I am going to just kind of shade the bits of the Venn diagram that are important to me, what I'm restricting it to. Okay, remember, so I want everything other than B because I want the probability of B not happening. So that is going to be 0.1 add 0.4. So my denominator is going to be 0.5. Okay. And the probability of A not happening given that B's not happened. Okay, so what's the only bit of my shaded area where A can't happen? So yeah, that is the 0.4 part. So that is going to become my numerator. So the probability of A not happening given that B's not happened is equal to 4/5, which is equal to 0.8. And that is as easy as that to get your full marks on a conditional probability question.